So test is Wednesday. It is going to be on Schoology. But we will have time to create your one-pager prior to that. Today, as we go throughout our notes, I'm going to use colored pencils. So if you just want to take out, I'm going to use, I think, 3 colors. Red, green, and blue. So if you want 3 colors, I'm going to use those 3 colors on our second example. And I'm going to use a Post-it. So I think most of you have Post-its in your bins. If you don't, let me know. I grabbed some extra. But I'm going to use 1 Post-it while I do these notes. Okay, so if you need a Post-it, they should be in your bin. You just need like 1 to peel off. What? You can use that. Okay, so if you need a Post-it, let me know. They should be in your bins if you want one. You guys have one? No. Alright. Let's get out your notes, last notes for the chapter. Alright, I'm going to set that stuff aside though. We aren't going to quite use it quite yet. We aren't going to quite use it quite yet. Yep. Alright, for problem 1. We are going to prove the alternate Samil. The alternate exterior angles converse. Okay, Samil. Alright, so what that means is that we are going to be given our if, and then we have to conclude the then part of the alternate exterior angles converse. So if we flip back 1 page, that was our 3-5 part 1. Our alternate exterior says if 2 lines are cut by a transversal so that our alternate exterior angles are congruent, then the 2 lines are parallel. So we're going to start by saying our alternate exterior angles are congruent, and we're going to try and prove that the lines are parallel. So on our problem here, we're going to draw a picture here, 2 lines, and the lines are cut by a transversal. Doesn't matter how you have your transversal, if it's going straight through, maybe yours is a little bit more angled, that's fine. And we want the alternate exterior angles to be congruent. So I'm going to label this angle 1. And my alternate exterior I'm going to label 2. So on the other side of the transversal, but on the outsides of the 2 lines. So that's going to be my given. That's what we're starting with. That's our if. If angle 1 is congruent to angle 2, we need to prove the lines are parallel. So we need names for these lines. What do you want one line to be named? We just use 1 letter. A. Line A. What do you want the other line? B. So creative. We're going to prove that line A is parallel to line B, and we use those 2 slashes for parallel. So when we prove a theorem, we can't use the theorem or the converse. We have to use some other converse or some other theorem that we know. Okay? So to start off with, we're going to create our 2-column proof. Does anyone remember in a 2-column proof? What goes in the first column? statements, and reasons. And what do we always start our two-column proof off with? Our given. Our reason is always given. And our statement is what we're starting with. What was given to us? What was the information? It was that angle 1 is congruent to angle 2. So we have to decide on a different converse that we want to use. We can't use the alternate exterior. We could do either the alternate interior, corresponding, or we could try to do consecutive interior. That would be a little bit more complex. Do you guys want to do alternate interior or corresponding?
Interior.
Okay, interior?
Yeah.
You sure?
Yeah.
Okay. All right, so how can I go to an interior angle from angle 1? Which interior angle would I look at? The one right below it or the one across from it? Yeah, let's do the one across from it. Let's call that angle 3 here. And what do we know about angle 1 and angle 3? They're vertical. So because they're vertical, we know that they are congruent. You leave it in there. And leave it in there until it's turn blue. Sure. All right, vertical angles theorem. Okay, I know originally Owen said he wanted to do the vertical angles, or what did I say? No. Owen wanted to do alternate interior angles here. Crushing it. There we go. All right. But if I know that 1 is the same as 2, and 1 is the same as 3. So 2 is the same as 1, 1 is the same as 3. What do I know next? 2 is the same as... There's no 4. If angle 1 is the same as angle 2, and angle 1 is the same as angle 3, angle 3 and angle 2 are the same. So 3 is the same as 1, 1 is the same as 2, so 3 is the same as 2. What property is that?
Remember, that's the one where we said if A is equal to B and B is equal to C, then A is equal to C. Exactly. Yep.
Transitive. And is this the transitive property of equality or of congruence? Are we saying things are equal or are we saying things are congruent? Congruent. So transitive property of congruence.
We know because we could look at that congruent sign.
We could go through and do that 2 is congruent to, we could make a new angle across that vertical. But at this point, if I look at 2 and 3, there's a relationship there. What is the relationship of angles 2 and 3? They're corresponding. And if corresponding angles are congruent, what do we know? They're equal. And the lines are parallel. So A is parallel to B. And we're basing it off of this 2 is congruent to 3. That's how we're saying this. So if I look at 2 and 3, I'm looking at that relationship for my answer to number 4. And what were 2 and 3 again? They're angles. What? Corresponding. So this is the converse of corresponding angles postulate.
How do we know when it's going to be converse versus just corresponding? Does anyone think they can explain that?
Nope.
That's a tricky part, isn't it? So we started talking about these theorems about angles, and then the last lesson, Thursday's lesson, was looking at the converse. So when we know information about the angles first, and we're going to parallel,
Then it's the converse.
when we know already the lines are parallel, and then we're going to information about the angles,
Then it's the theorem.
then it's the theorem.
And we're going to use that a little bit more in this next problem. So we'll kind of get a chance to check that out.
It is confusing. That would be something really good to put on your one-pager tomorrow. A note to self about how to know when it's the converse or not. And if we want to talk through it more as we go today and tomorrow, we can do that.
Okay, number 2. We're going to start with kind of this diamond-shaped shape. Diamond-shaped shape. We're going to start with A. B is going to be on the left.
So those are points. Point A, point B, point C, and point D.
We're going to have at point A, that angle that's made is going to be angle 1. The angle at point B is angle 2. And then the angle made at point D is angle 3. We're going to pare it back a little bit. Okay, so that's the drawing that we're given. So we know we see that drawing. We also are going to be given that angle 2 is congruent to angle 3. And we know that BC, segment BC, is parallel to segment AD. So those are the things we know. What we need to prove is that AB segment AB is parallel to segment CD. So I like to mark up what we're given. So what we're given is that angle 2 is congruent to angle 3. So I'm going to mark those with those angle, the arc. So angle 2 is congruent to angle 3. So I know those are the same. And I know that BC is parallel to AD. We can go ahead and start our proof with that, because our proof just starts with given. We don't really need to do too much thinking for the statements to start. So what's kind of silly here is that when we wrote given, we probably could have just written it straight into our proof, but we're pretending it was like typed out for us. All right, so if I'm looking at those two red lines, BC and AD, I want to think about a transversal that connects BC and AD that we can talk about two angles with. So which transversal cuts across BC and AD? Say it again. You want me to say it again? When I look at BC and AD, what segment connects them or crosses through both of them? CD and BA. With CD, we only have one angle there, so we're not going to pay attention to that one. We're going to look at that AB. So I'm going to cover that up. This is where the post-it kind of comes in place. I'm going to just ignore the other parts just for a moment. When I look at these two red lines and that transversal that cuts through it, I'm going to put that transversal as blue. What kind of relationship do you see between angle 1 and angle 2? They kind of look the same in the picture that I drew. What kind of angles are they? Next to each other, so they're on the same side. Consecutive interior. So if you flip back, what do we know about consecutive interior angles? Yeah, they add up to 180. They're supplementary. So we knew that those angles, or those lines, were parallel. Because we knew the red was parallel, we know these two add up to 180. So that's going to be our next statement. Statement number 2. The measure of angle 2 plus the measure of angle 3. Nope, not 3. 2 and what? 1 is going to equal 180 degrees because we knew that they were parallel. We started off by looking at the parallel lines. Then we said, yep, 2 and 1 are consecutive interior, so they add up to 180. So when we start with the parallel lines, then go to the angles, that's just the theorem. So consecutive interior angle theorem. Eventually, though, I want to be looking at what two segments? What are we trying to prove? That AB is parallel to CD. So I want to somehow connect to what I just said, measure of angle 2 plus measure of angle 1 equals 180. And now I want to be looking at my blue to blue. So what pair of angles are connected between the blue lines? 2 and 3 don't have a one transversal that cuts through them that connects them. Which one are connected by a line? So here 2 isn't connected with anything, but 1 is connected to 3. We knew that 1 and 2, these two added up to 180. Do I know that these two would add up to 180? What do you know about 2 and 3? They're congruent. What does it mean to be congruent? What's the same? The measure. So measure of angle 2 is equal to the measure of angle 3. remember? What's that definition? Definition of
Well, we use so much.
congruent angles. Yep, anytime we go from that congruent to equals or equals to congruent. Definition of congruent angles, and I just simplified the angles by drawing an angle. So for my statement number 4, I'm going to take this number 2. And instead of saying measure of angle 2, what can I swap that out with? 2 is the same as what? 3. We just said that. 2 is the same as 3, so I can put 3 there. Measure of angle 3 plus, and then we keep the rest the same. Measure of angle 1 equals 180 degrees. So what do we call that when we swap something out that's equal? Substitution. Alright, now if we look at 3 and 1, we know that they add up to 180. So if I take a look up here, I'm going to cover up the 2. This is why I have my post-it, so I can just kind of get rid of that just for a second. If I look at 1 and 3 and I know they add up to 180, what 2 lines are going to be parallel because of that? You can use a color if you want to say mine. If you colored yours, you can say your color, but what 2 angles will be parallel because 1 and 3 add up to 180? Yeah, that A, B, and C, D, my blue lines. This line is going to be parallel to this line. Okay. So I didn't have to think about that 2. I just wanted to kind of cover it up. In my brain, I like to cover up the whole thing. Okay, because what kind of angles are 1 and 3? What is their relationship? They're supplementary. Which theorem or converse would we use? They're interior. They alternate interior or alternate interior or consecutive interior? Consecutive. So because we know that they added up to 180, that tells us that they are parallel. And to get our reason here, we're really thinking of this reason here. Why that told us. And that's because that 3 and 1 are consecutive interior. And this time we're going to use that converse because we said that they were parallel. That was our conclusion. All right, that is it for our practice today. Or not practice, that's it for our notes today. So you have the rest of the time for practice. It is in the week 10 folder of Schoology. It's going to be a lot of drag and drop. It might feel like a lot because you're going to see a lot of things that you can drag over. But just take it step by step. If you need to, take out a Post-it to cover up parts of the picture. Or maybe take a Post-it so you can draw it out. Or maybe use a whiteboard.